Hello again. So this is the second video, and we're talking about the agenda for today. Learning target is focusing on the graphs of inverse functions and specifically about logarithmic functions. Last week we talked more about a logarithm as an operation, so like how plus and minus have operations. And now we're going to try to extend that a little bit and talk about it like a function. Okay, so a function, we'll review what a function is. We'll talk more about inverse functions. So we did the warm-up already. We'll talk about inverse graphs. And then we'll talk about logarithmic graphs and finish up with the exit ticket. Okay, so please be ready. Take some notes here. Definition of an inverse here. Like I said, last week we talked about inverse operations. Now we're talking about inverse functions. Again, I want to pause. Think about 2 minutes again of think time. What does an inverse function do? What does an inverse operation do? And if you can come up with examples, that's great. So please pause, about 2 minutes of think time. Go ahead and respond in the chat too. So now you've had a little bit of time to respond in the chat. Hopefully some answers came up. Inverse operations undo each other. So inverse operation undoes or undo. And so for our examples, we have plus versus minus. We have multiplication versus division. We have powers versus roots. So something like if you have x squared, and then I'll do slash square root of x. And our most recent one is if we had, say, 2 raised to the x versus log base 2 of x. And so those two things are inverting each other. And when you think about a function, an inverse function, they also undo each other. But what we want to think about is undoing each other, not just for a specific number, but for all values. And so, for example, we can have a function like f of x equals 3x versus g of x equals, what's the opposite? Dividing, so x divided by 3. So that's just a quick example. We'll talk a little bit more about that in the next few slides. Okay, moving on to the next slide here. Inverse functions. So just really digging in, you all have seen this definition a few times. Functions take the domain and spit out the range. Every value in the domain has a unique value in the range. And you can think about this like your keyboard. If you hit a button on your keyboard, it does one function on your screen. Every time I hit the button J, it types the letter J. It doesn't type other letters. My computer would not be functioning if I typed a J, if I hit the J key and I saw a K or a Q or a plus. Similarly, a mathematical function, you type an X, you plug an X in, and you get out a unique, consistent Y value. And domain is all of the X's you are allowed to plug in, and range is all the Y's you are getting out from the function. Now, when we look at this, the function taking in X and spitting out Y, the word inverse meaning undo it. Think about what that would mean. What that would mean is that an inverse function undoes the function. Inverse function takes Y and spits out X. So it literally reverses the order. It doesn't change numbers from plus to minus. It doesn't change numbers necessarily from a fraction to a whole number. It switches your X and Y. So keep that in mind because that's a common misconception. People try to do all kinds of fancy things with the function. It takes the Y's as is, the exact Y values from the original function, and it spits back out the corresponding X values. That's what a function does. I'll show you just one other slide here in this video, and then we'll go to a third video just so they don't get too long. Here's a quick example. Function on top, f. The notation that we use for an inverse function kind of looks like an exponent. It's not really an exponent. It just has the same symbol. And -1 is not power. It is just saying the inverse function. And what you can see is we have the map on top. ABC is mapped to 1, 2, 3. And on the bottom, that is reversed. If I wanted to use function notation, I can say f of a is 3 because the a has an arrow pointing to 3. F of b is 1. F of c is 2. Now, when I want to make the inverse, I don't change those numbers. I don't put negatives. I don't put fractions. I keep the numbers and the letters as is. I just reverse. F inverse of 1 is B. That's just taking this arrow from the original map and reversing it like that. F inverse of 2 is C, and F inverse of 3 is A. Keep the values exactly as is. I can't stress that enough. And reverse the X and the Y. So I'm going to stop this video here, and we will do one more video of notes before we go on to the activity.